Okay, so we have done some of our basic stats in Excel, and I want to talk to you a little bit about what numbers you should always report from those stats. And so I want to get you in the habit of reporting these numbers every time, so let's talk about them. So we've already talked about descriptive stats a bunch. You always report central tendency, spread, and sample size. With the inferential stats, there's also basically three things you always want to report: the p-value, the value of the test statistic, and the degrees of freedom. So let's get some examples. Let's talk about each of these individually first. Of course, the p-value is the most important value, and you're going to report that. Every stat calculates a test statistic, and most programs will give you that stat, and you also want to report the value of the test statistic. And every test stat has what are known as degrees of freedom, often represented by DFs, and it's sort of related to the n size, and they can vary depending upon your experimental design and what kind of test stat you use. And so just reporting the n size is not enough. You always need to report the degrees of freedom too. And this is just by convention. These are the basic numbers that are always reported, so I want you to get in the habit of doing that. So let's look at a t-test example. Here's some output from Excel. And the t-test always gives you the descriptive stats, so you've got those there, which is nice. Here is the value of the test stat. If you look, you see that it has t-stat. That's our test statistic. It's called t. And so the value of our test stat is negative 0.97. If you look here, it's labeled DF. Those are our degrees of freedom, which is 18. And then here is our p-value. And remember, if you have a choice, always pick the two-tail p-value. It's more conservative. It's better from a philosophical standpoint. So that's the one I want you to use. And so now that you have these numbers, how are you going to report them? In the text, there is kind of a standard formula I want you to use for reporting these values. First, tell us the decision about the null. Do you reject the null or fail to reject the null? Give all those stats in the parentheses. So the test stat, the degrees of freedom, the p-value, give those in parentheses. And relate the decision to the question of interest. So I always want you to, bring back the question you're working on, relate these things to the biology, okay? So you're going to be giving us some statistical results, but don't forget, these things are in the context of a biological question you're trying to answer. And so you want to bring the results back to the original question. So let me give you an example of that. Based upon the t-test results, we fail to reject the null. T equals negative 0.97, degrees of freedom equal 18, P equals 0.34. Ink type did not influence the behavior of the termites. So you see how I tell you about my decision with the null. I give the proper statistics, and then I relate it back to the original question. Now I want you to note here, I only use like 2 significant digits. I don't know that there's a real rule about this, but there's no reason to go more than 2 significant digits. Even though the software gives you like 8 digits, don't use them all. It's just ridiculous. So just round everything off to 2 decimal places, really. And here's a template that I suggest you use when you're writing your reports. Based upon the blank results, so it would be a t-test results or ANOVA results or regression results. We fail to reject the null or we reject the null. That would be the second blank. And the test stat equals something, the degrees of freedom equals something, the P equals something. And then another sentence, something relating this to the original question. If you can use this template, then you are always going to report everything you need. And that makes me happy. All right, let's talk about regression. Here are the regression results we get from Excel. In regression, you've got two continuous variables. You don't have discrete groups, so you don't often calculate descriptive stats in the way that we did with the t-test or with the ANOVA. So we're going to skip the descriptive stats. The regression gives you an F value. That's the test stat for regression. It's called F. So F equals 61.54. F is unique in that it actually has two different degrees of freedom, one for the numerator, one for the denominator. You always must report both, and you got to keep them separate, right? You don't want to say there's 9 degrees of freedom total. You want to keep them separate, numerator, then denominator. So 1, 8. And then there's the p-value. And remember, for the regression output, you just want the p-value associated with the slope. In regression, we also get an R-squared. The adjusted R-squared is the most conservative, so that's the one we want to report. In this example, R-squared equals 0.87. So in a similar way as before, we would say something like, based upon the regression results, we reject the null. F equals 61.54, degrees of freedom equals 1 and 8. P is less than 0.001, R-squared equals 0.87. Temperature had a significant positive effect on swimming speed. Again, our decision about the null, the stat values, and then relate it back to the question. Although we use the adjusted R-squared, we never call it that. We just use the R-squared. Another thing I want to point out is that when P is very small, as it is in this example, you don't usually report its exact value. If it's less than 0.001, that's good enough. So report it that way. Also, if you have a significant regression, you can tell the reader whether it was a positive relationship or a negative relationship. So if the value of the slope is positive, that's a positive relationship. If the value of the slope is negative, that's a negative relationship. Positive means as the independent variable goes up, the dependent variable goes up. Negative is as the independent variable goes up, the dependent variable goes down. Just look at the value of the slope in the regression output. All right, finally, here we've got some ANOVA results from Excel. Now we again have discrete categories, and so we can do descriptive stats, and the ANOVA table gives them to us. Here you see the value of F, so we have the same test stat for ANOVA. Since it's F, it has two separate types of degrees of freedom, and you also see the p-value, all reported right there. Now remember, in an ANOVA, if we reject the null, we have to do separate tests called post-hoc tests to determine which groups are different from which other groups. And those results must be reported as well. And so you would say something like, based upon the ANOVA results, we reject the null. F equals blah, DF equals 3 and 18, blah, P equals blah. February and November had the highest food consumption, while May had the lowest food consumption. Note, often when you try to explain the ANOVA post hoc results, it sometimes gets awkward. There are many reasons, and I'll show you. If you have to do an ANOVA, I'll show you what I'm talking about. Don't sweat it. But you still have to report those ANOVA results, or the post hoc results, okay, if you have a significant ANOVA. If you fail to reject the null, then you're done. It doesn't matter. You don't have to do post hocs. Okay, so those are the things that I would like for you to report when you do your inferential stats. Don't forget, you also want to include the inferential stat results in your figures and in your tables. Put them in the caption, put them somewhere on the figure. So there's going to be sort of two places where you report these results. And that's all I have for now.